name is Mona Nemer, and I'm the Chief Science Advisor to the Canadian Prime Minister and his cabinet. I'm delighted to be here today and moderate priorities and collaborations for global recovery and international perspective. Around the world, we're seeing leading nations from the G7 and G20 putting science and technology at the heart of their recovery plans, and in some cases, at the heart of cross-government thinking. Scientific issues, after all, have implications for practically every area of policy, net zero to physical and mental health, agriculture, transport, security, emergency preparedness. So how do we ensure that we're leveraging science? How are leaders around the world putting science and technology at the heart of their post-pandemic recovery to position themselves for a greener, safer, and more prosperous future? To help answer these questions, allow me to introduce our esteemed panelists. We have with us Patrick, Government Chief Scientific Advisor and Chief Technology Advisor to the Government of the UK. Kei Koizumi, Principal Deputy Director for Policy in the White House Office of Technology Policy, known as OSTP. Senior Razzo, Deputy Director for Research and Innovation at the European Commission. And last but not least, Professor Mishinari Hamaguchi, President of the Japan Science Agency, and I want to particularly thank him for joining us. It's right now 2:30 a.m. in Japan, so thank you so much for joining us. I'm looking forward to hearing from all of you today. Specifically, our focus is on how these leading jurisdictions are putting science and technology at the heart of their recovery plans, be it in relation to economy, health, the environment, public safety, and emergency preparedness. Some introductory statements from the panelists, and I will not provide any lengthy introduction of them. You have their bios. And after they each give us their perspective, we'll have question and answer period. I'll start by asking some questions and encourage the audience to please put your questions in the chat. Ask them on your behalf. So let's get turn to you, Patrick, to start us with this panel. So over to you.
Thanks very much, Mona, and it's a great pleasure to be here. I was thinking about the origins of my role when I was preparing for this panel, and I'm the UK Government Chief Scientific Advisor. That role was created after the Second World War, when it was realized that science had been so important during the war that ministers asked the question, couldn't it also be important during peacetime? When I joined government, my aim was to try to get science right at the heart of decision-making in government and to make it as embedded in the way policies were thought about and decisions were made as economics has been across government. What I did not realize, of course, was that there would be a crisis of the dimensions of the pandemic that would indeed put science right at the heart of government. And I want to spend just a few minutes talking about the things that we've seen during the pandemic and how that has fed into where science fits into the government for recovery and for the future. So there were really three areas that were important during the pandemic: science advice for policy, science for understanding and tracking the pandemic, and science for the response to the pandemic. And in each of these areas, there are lessons that can be learned for the future. So the science advice for policy in the UK was delivered both by individuals, me as Government Chief Scientific Advisor, the Chief Medical Officer, institutions within government, such as Public Health England, but also by a group that we form when there is an emergency, the Science Advice for Government Emergencies, which is an external group, largely, mix of external and internal, that provide detailed expert advice into a committee that can then consolidate that advice and give it into government so that there is a unified consensus position with uncertainties expressed. Because, of course, the science advice must come with uncertainties. It must come with an understanding of how will be resolved or how they could be resolved and what needs to be done to get to those resolutions. SAGE has become the mechanism for giving integrated science advice throughout the pandemic. But on top of that, there have been many meetings where, right from the beginning, from January 2020, we asked, what is the position that science can play here? And that ranged from getting science funders together to try and tackle the big problems of the day, through to stimulating work on genomic surveillance, clinical trial integration, and research of scientific problems. So if I quickly run through those areas, science advice for policy was largely given through an established mechanism of bringing outsiders in. And that outside in is an important point. Science advice, or science for understanding and tracking, needed the creation of new mechanisms, so that the Office for National Statistics was set up to do something it had never done before, which was to create a survey to measure regularly, twice a week, to take random sampling across the country to monitor the progress of the pandemic across different populations, different socioeconomic groups, different regions, and to provide an unbiased sampling of what was going on. And that's a new role for the Office for National Statistics, and one that I suspect will continue as a public health measure going forward. We also managed to pull together a genomics consortium very early on to sequence the virus, and that at one point early on meant that 50% of all the genomic sequences were being done in the UK, which was a consortium of academic organizations brought together to work together to tackle an immediate government priority. And on top of that, we created a function, the National Core Studies, to bring together across a number of areas, different groups, again, to come together to work in a collaborative way with funding that was got through quickly in order to address government priorities. It's worth just reiterating that, because that's not normally how things work. And the question, of course, is how might such mechanisms also be useful now? And then science for response included a vaccines task force being set up. That required bringing in people from industry, academia, experts on manufacturing, together with scientists, engineers, and others, right the way into the heart of the civil service. And that had to operate differently. It had to operate quickly. It had to operate building on true expert advice to make decisions linking through to R&D funding, procurement, and indeed deployment. And this notion of a rapidly assembled, diverse expert group with a clear mission, a clear output, and empowered leadership that was able to make decisions, I think is a model which the UK government is looking at to say, what else can that be useful for? That sort of model of bringing together those people quickly with empowered and authorized leadership. We were able also to bring together clinical trials in a way that hadn't ever been done before. The recovery study, which was one of the largest studies in the world and gave some of the early answers around the effects of steroids, for example, meant that at one point during the pandemic, 12% of all patients in hospital were enrolled in this study. 12% of all patients with COVID in hospital were enrolled in this study. That is massively higher than one normally gets for trials, and tells you what is possible in terms of answering questions that are relevant to healthcare systems if there is a will and desire and design to do so. And the final sort of general point on studies is social sciences were incredibly important throughout this. And the integration of sciences across physical sciences, biological sciences, engineering, and social sciences was absolutely instrumental. And the ability of social sciences to work quickly, to come up with answers and advice for government is something that we need to build into the system going forward. My next major point is around international. It's been crucial to have international colleagues, and Mona was certainly one of those that we spoke to a lot. But we had regular meetings right the way across the world with science advisors to learn from each other. I think there has never been more collaboration between national science advisors facing the same problem. And we've seen what power that can bring. And the power has not just been how we talk to each other, but the ability of each of us to go back to our respective governments and say, it's not just us that's thinking like this, it's these other countries as well. And that carries a lot of weight and again provides a lesson, I think, for how we might think about bringing consensus science advice into governments in a way that carries weight and people can respond to. The other groups that we used often were the academies, the learned academies. In the case in the UK, the Royal Society, the Royal Academy of Engineering, and the British Academy that deals with social sciences, arts, and humanities. And each of those academies were commissioned by me at various points during the pandemic to provide reports rapidly. The Academy of Medical Sciences produced 2 reports on winter. What was winter going to look like last year and this year? The Royal Society did work rapidly to answer questions of relevance. The British Academy did a report on what society might look like post-COVID and what that meant for policymakers. And the Royal Academy of Engineering did work on ventilation, amongst others, how the buildings of the future need to look in order to be both resilient to climate change and to infection. So the use of academies in rapid response, very focused on clear policy issues, has been incredibly important and will remain so as we enter this next phase, and has already laid the foundations of what certain aspects of recovery look like. Finally, just 2 points. We have established now, and I think it was in part due to what's happened over this past 2 years, an Office for Science and Technology Strategy at the very heart of government that brings in an integrated approach to policy for science. Not just what do we fund in the universities or the research institutes, but how we think about everything from skills development, government procurement as a tool to pull innovation, the aspects ranging from housing required for researchers through to the ability to use big defense procurement as a way to pull through certain things. How does government centrally run that, and what the science advice is needed, which has led to the establishment of a prime ministerially chaired committee, the National Science and Technology Council, that will take this forward at a cross-government level. So cross-government working is something that's crucially going to be important, and it's now got a structure which allows it to be ministerially led and owned and driven in terms of the delivery of the output from science advice. So already we've seen a change in structure. We've seen an ability to do this more, building on the lessons from COVID. And this is going to be crucially important, of course, as we enter the other great challenges that we all will face. And the obvious one is climate, which requires many of the same mechanisms, many of the same approaches, and certainly requires the internationalism that's been so important during the pandemic. But it's one that's going to be durable and last for many, many more years, of course, than the pandemic will. So those lessons will be applicable, they will be relevant. And one thing that we found, and I suspect others have, is that ministers are now calling for science advice. They want to get data visualization to help them understand the evidence base and how that's changing day on day or week on week or month on month. And so there has been a change in the political appetite for science advice, the ability to deliver science advice, and crucially, the role of data integration, data flows and analytic through to data visualization to allow ministers to make in-stream decisions and understand the consequences of those decisions. So I believe there has been an irreversible change which is a good time to build on it as we face a series of other crises, as Mona laid out in her introduction. I will stop there, Mona.
Thank you very much. Thank you very much, Patrick, for this comprehensive, I think, overview of what the UK has done. And thank you so much for being such a great colleague, collaborator as well. So over now to Kay, please.
Hello, everyone. I'm Kei Koizumi. I'm the Principal Deputy Director for Policy at the White House Office of Science and Technology Policy. I'm delighted to be here with you today. This is my second CSPC. My first was as an attendee, so I'm honored to be a presenter this time around. I'm speaking to you from the White House, and I want to acknowledge that it is on the lands of the Anacostan and Piscataway peoples. And before I start, je voudrais remercier les organisateurs de cette conférence canadienne d'avoir accueilli ce panel. On a l'occasion de découvrir ensemble la façon dont la science et la technologie peuvent renforcer le rétablissement de notre pays. So the United States is placing science and technology at the heart of our recovery plans, and we are building back better on multiple fronts. First, of course, we are harnessing science and technology to recover from the global pandemic. We're guided by President Biden's charge to Eric Lander, his science advisor and the director of OSTP, and indeed, a charge to the entire science and technology community. He asked us, what can we learn from the pandemic about what is possible or what ought to be possible to address the widest range of needs related to our public health? To answer the president's charge, in September, the administration released the American Pandemic Preparedness Plan to utilize science and technology across the US government to all better prepared for the inevitable next pandemic. The US has the opportunity and need to fundamentally transform our S&T capabilities. To ensure that the United States and the world are properly prepared, the work to develop these capabilities needs to begin now. This plan is an element of the administration's strategy on biodefense and pandemic readiness and is informed by lessons from the COVID-19 pandemic. Guided by science and technology, we're undertaking critical work to strengthen US capabilities to respond rapidly and effectively to any future pandemic or high consequence biological threat. The work is organized around 5 pillars. First, transforming our medical defenses. Second, ensuring situational awareness. Third, strengthening public health systems. 4, building core capabilities. And 5, managing the mission. Also in response to the president's charge, we are collaborating with international partners under the leadership of Sir Patrick Vallance in the United Kingdom in the 100-day mission to push the boundaries of what's possible to have vaccines and therapeutics available for the next global health crisis within 100 days of the outbreak being identified. That is an ambitious challenge, and we can only do this together. Third, the pandemic all of us inequities and missed opportunities in our health system. In recovering from the pandemic, the Biden administration recognizes we have to pursue breakthrough approaches in solving long-standing health challenges. To do that, President Biden has made it a personal priority to launch the Advanced Research Projects Agency for Health, or ARPA-H, which will make breakthrough advances in health and get them to patients quicker than ever before. We're enthusiastic about the possibilities of ARPA-H. This is because science has enabled some amazing things over the last few decades, such as training our own immune system to fight cancer and developing safe and effective COVID-19 vaccines in less than a year. And now we stand at an unprecedented moment of progress that challenges us to ask, what more can we do to speed and revolutionize medicine and improve the health of all Americans? How can we transform healthcare access, equity, quality, and all of that to reduce health disparities. But that is not the only recovery that we are focused on. We are also for harnessing science and technology to recover from the economic crisis engendered by the pandemic. Here again, we're guided by President Biden's charge to OSTP and the science and technology community. His charge was, how can the United States ensure that it's the world leader in the technologies and industries of the future that will be critical to our economic prosperity and national security, especially in competition with China? Our aim is to harness science and technology for a sustainable recovery with well-paying jobs for Americans. For that, we are partnering with like-minded nations. Briefly, and I'm sorry. And in order to do that, we are engaged in establishing science and technology collaborations with Australia and with the United Kingdom in quantum information sciences, for example. We are also engaged in laying out an ambitious science, technology, and innovation agenda, many of the pieces of which are currently before our Congress. Last week, the President signed the Infrastructure Investment and Jobs Act into law, which provides billions of dollars in clean energy research that will be key to the clean industries crucial to our shared economic and environmental security. Last week, our House of Representatives approved the Build Back Better Act, which provides billions of dollars in research and development and other S&T investments to ensure the technological, security, and economic competitiveness of America in key economic sectors. We hope to have final passage of this in coming days. And we are also working with our Congress on the U.S. Innovation and Competition Act, which provides the policy framework and billions of dollars for R&D investments to ensure sustained economic recovery by investing in semiconductor capabilities and other key technology sectors. So third, we are also harnessing science and technology to recover from the planetary crisis engendered by climate change, a crisis that of course is still going on. And we are guided by the President's charge. How can breakthroughs in science and technology create powerful new solutions to address climate change, especially in communities that have been left behind? The nations represented on this panel came together at the recently concluded COP26 summit to raise our ambitions for climate action. I'm here to say that in US actions and commitments, science and technology are foundational. First, OSTP, in our leadership of the US Global Change Research Program, supports American research into global climate change and ensures that our scientific findings inform all facets of decision-making about climate change. We do this collaboratively with our international partners in our shared participation in the Intergovernmental Panel on Climate Change. Second, at COP26, we announced, in collaboration with chief science advisors from around the world, that we will examine the strategic steps necessary to reach net zero greenhouse gas emissions by 2050. We announced that multiple nations will work together to develop national science and technology roadmaps to undergird commitments to achieve a net zero emissions world. We look forward to deploying the full creativity and capabilities of science and technology to develop, deliver, and then deploy solutions. For the United States, that means developing energy transition roadmaps to the year 2050. And finally, for this priority, we're investing billions of dollars in our infrastructure legislation and soon the Build Back Better Act to help our natural environment recover from disasters exacerbated by the impacts of climate change. We're investing in coastal and ecosystem restoration, wildfire recovery, and we are building science and technology into climate mitigation, adaptation, and resilience. I could talk, if we have more time, about other recoveries guided by science and technology. We're also harnessing science and technology to recover from a societal loss of trust in information of all kinds, including scientific information. These losses of trust have been exposed for all of us by this pandemic. We are also trying to recover in science and diplomacy. We are working to use science and technology to recover from the pandemic, closing off our global personal travel and scientific connections over the last 2 years. Now, in all these recoveries, I want to conclude by saying we are building back better together, as the North American leaders declared last week at the US, Canada, Mexico summit at the White House. For this CSPC, I want to call attention to one example. Last week, we announced that the United States and Canada will work to define a bilateral science, technology, and innovation agreement that is intended to amplify our cooperation and help us work together to address the most pressing science-based priorities faced by our two countries toward concluding an agreement at the earliest possible opportunity. Thank you all for the chance to offer the United States perspective on science and technology priorities for the global recovery and to identify collaborations. I know we have many collaborations and much science and technology to consider in days to come.
Thank you very much, Kay, and it's been a pleasure to work with you over the years in your different positions. We're delighted that the friend and supporter at the OSCP, and just like you mentioned, so many things to do. So now I would like to ask Sinia to please provide us with the EU perspective, and I believe you have some slides to share.
Yes, well, many thanks, Muna. Dear panelists, ladies and gentlemen, it is my great pleasure to participate to the annual Canadian Science Policy Conference for the first time, as I know that it is really a major global forum. Let me start by providing an insight of the European Union's Research and Innovation Framework Programme, Horizon Europe, in order to highlight what the EU has been doing and preparing on the scientific front, both before, during, and after the pandemic, and how our program will guide us and enhance our recovery from the pandemic. So let me share with you some slides. Now you can go to the next slide. So first, I will just say a few words about the structure and new elements of Horizon Europe, our 7-year research and innovation program. Then we'll also provide some elements how international cooperation and association are core to our thinking. So let me first say a few words about the structure of Horizon Europe, and you can now go to the next slide. Horizon Europe is a program which is built on certain principles that guide its composition and its mission. As such, its very structure reflects the most important priorities of the European Union. In fact, Horizon Europe is a program which simultaneously encompasses and tackles all the major policy priorities established by the European Commission, and in particular, the European Green Deal, the digital transition, and an economy that works for people. Horizon Europe is the EU's core instrument and lever for research and innovation, and it has been endowed with a budget of nearly 100 billion euros for 7 years, making it the largest of its kind in the world. And its purpose is to tackle climate change, achieve the UN's Sustainable Development Goals, and boost the EU's competitiveness and growth. The framework program also supports the creation and dissemination of excellent knowledge and technologies for the good of the people globally. It is designed to engage the widest possible pool of talent within the EU, Europe, and anywhere else in the world. It strives to bring knowledge to serve protecting human lives, communities, and to boost sustainable economic growth in Europe and beyond. Horizon Europe is structured along three main pillars. These are excellent science, global challenges and industrial competitiveness, and open innovation. Now, with this next slide, I'd like to illustrate how Horizon Europe is helping to foster our green-led recovery, which is at the core of today's exchanges. And it is also useful to briefly go over two of our programs clusters, which are part of this global challenges pillar. Clusters, by the way, represent areas under which we organize and fund research. And just to illustrate, I'd like to highlight first the fifth cluster, which is entitled Climate, Energy and Mobility, which aims to fight climate change by helping understand its causes, evolution and impacts, and by making the energy and transport sectors more climate and environment friendly. Another example would be our sixth cluster, which groups together food, bioeconomy, natural resources, agriculture and environment. And this aims to reduce environmental degradation, halt, reverse the decline of biodiversity, and better manage natural resources. And the research which we fund and encourage through this cluster will enable to steer accelerate transition to low carbon, resource efficient circular economy and sustainable bioeconomy. In addition, Horizon Europe also creates EU missions, which is a new way to bring concrete solutions to some of the greatest challenges that we face globally. And missions deliver impact by putting research and innovation into a new role, combined with new forms of governance, collaboration, including engaging citizens. And the philosophy around missions is a strong interdisciplinary approach, which will result in a cross-cutting work, pooling the necessary resources together. And you can see some of the challenges that these missions address. Now, let me, with the next slide, turn into the recovery plan, because this type of approach has become foundational in the context of the pandemic and the post-pandemic. It was instrumental also in devising our economic recovery from the pandemic, in particular with the recent Next Generation EU initiative, which will see EU member states invest significant resources in the digital and green transition, as well as in research and innovation. So 80% of the funds will be directed to support public investment and structural reforms in member states, but it also aims at strengthening resilience, autonomy of Europe's strategic sectors for a sustainable economy. And as the crisis underlined also the value of European cooperation and the capacity to quickly react to future shocks, now we've also decided to reinforce our instruments to create EU for Health program and also upgrade Horizon Europe. Now, with on the next slide, you will see research and innovation actions in the recovery context. A very concrete example has been our ERA versus Corona action plan, which we really started very quickly already at the beginning of 2020 under our previous program, Horizon 2020, but still many projects are still ongoing, and new calls of tackling COVID-19 have been published last spring. Just a couple of projects to illustrate that. The Remap CAP project, for instance, uses an innovative triangle designed to better treat pneumonia, which we know is associated with COVID-19 related mortality. And finally, let me spend a few moments with the next slide on our international cooperation in Horizon Europe. Namely, I'd like to insist on the importance of international cooperation under our framework program, mentioning in particular the possibility of association of non-EU countries to the program, because research cooperation between the EU and international partners, including association, has been proven to be a clear-cut win-win situation for everybody involved, including the researchers, universities, and companies, both in Europe and in our partner countries. And Horizon Europe regulation has brought a novel element to the table, namely the possibility of extending association to countries outside the EU's immediate neighborhood. This is a possibility which has not existed before. Say what has changed, to put it shortly, developing close relations with like-minded countries of excellence, no matter their geographical location, and association to Horizon Europe, in particular to the second pillar, which I described earlier, which is devised really to tackle global challenges. Now, what about Canada? Now, after Canada has expressed its interest in this option, and formally, we've started the exploratory talks in July this year, and now we are progressing in our talks and very much hope that the formal negotiations for Canada's association to Horizon Europe can start in the coming months. So finally, let me reiterate how much we value international cooperation, and we sincerely believe that by putting science at the heart of our recovery, we'll not only be able to overcome the pandemic, but also we will be better prepared for major challenges also in the future. Thank you very much.
Thank you very much, Signe, and I too look very much forward to concluding actually negotiation positively with the EU. Our Prime Minister expressed the interest and to join and formalize our collaboration. So let's hope that this gets underway, and look forward as well to welcoming you back in Ottawa, and in fact welcoming back all the colleagues in person next year, hopefully. So to finish this very important, I'd like now to invite Missionary to tell us the very interesting things that are going on in Japan when it comes to science and technology, and the roadmap that he has put forward for the years to come. So over to you, Missionary.
Okay, thank you very much for your kind introduction. I will speak briefly on how Japan is putting science and technology on the earth, and also how we, Science and Technology Agency, JST in short, are contributing to these initiatives. In 2016, the Japanese government announced the 5th version of its Science and Technology Basic Plan. It introduced of Society 5.0, an inclusive society where diverse lifestyles can be accommodated and promoted through digital technologies. This Society 5.0, however, was envisioned before the COVID-19 pandemic, when its plan was issued early this year. It emphasized the importance of disaster preparedness and creating a society that is sustainable and resilient against threats and unpredictable and uncertain situations, that ensures the safety, security of the people and realizes diverse well-being. The 6th plan welcomes a convergence of knowledge and for the first time integrates humanities in science and technology activities. So, in essence, the government envisions a technology-driven yet human supports diverse lifestyles and well-being and is resilient. Our organization prioritized these notions of convergence of knowledge and promoting more international, interdisciplinary, and intergenerational cooperation. We are on silos and bridging the gap between science and society. One of our programs funding research with real society value is LISTEX. It employs knowledge from hard social science and humanity, tackling topics that are not normally approached by the sciences, including social isolation and loneliness and child poverty. This is really critical in Japanese society. Research goals, it is also important to accommodate the voice of young people. Today's decision must pair the toolkits and the environment for the younger generation to use their own ideal future society. At JST, we recently welcomed the opinion of young researchers for our millionaire programs. In this program, 21 young research teams were selected to brainstorm their vision for an ideal 2050 society. We spent almost 6 months for discussion to create new research goals for JST's Moonshot R&D program. Moonshot is a large program with fundings of over $1 billion supporting research of up to 10 years and promoting a diverse range of projects such as ultra-early disease prediction and intervention, co-evolution of AI and robots, and creating a fault-tolerant universal quantum computer. However, in the wake of the COVID-19 crisis and the needs for more resilience, the Millionaire Program invites these young people to create additional moonshot goals compatible with the new normal. 21 teams presented their findings. The following 2 new moonshot goals were selected. In our first goal for 2050, we aim to control increasingly severe typhoons and torrential rains by changing their intensity, timing, and extent of occurrence in order to significantly reduce the damage caused by extreme wind and flood events. Climate resilience with regard to typhoons and torrential rains has focused so far on preventing damage through warning systems and the improvement of buildings. However, in addition to these passive approaches, we would like to tackle these issues actively by directly controlling the weather phenomenon. It's really challenging. In this slide, simulation shows that storm disasters can be reduced by artificial intervention. Left side one. If you increase the pressure 5 hectopascal, just a small amount, you can decrease 1.8 billion US dollar worth of economic loss will be this. So it's really challenging project. Our second new goals for 2050, we aim to increase peace of mind and vitality for a mental healthy and dynamic society. We will create technologies and significantly enhance empathy and creativity and provide mental support service based on these technologies. The digital transformation and the use of cyberspace are improving convenience of life. However, the complexity of our sensation, our emotions, our thoughts, and more are not sufficiently taken into account. We need technologies to improve psychological resilience in order to emotionally cope with a crisis and move smoothly onto a post-crisis state. Left side graph, we can show, this graph shows that papers related to mental health increase rapidly after the pandemic. Of course, both of these new goals have their own practical and ethical issues to consider. However, I hope you can see how inviting young to the program results exciting and inspiring ideas. I look forward to seeing their program. Another JST programs fostering early career researchers is Forest, newly launched last year. We provide long-term support for unrestricted, challenging, and fusion-oriented diverse research. We found that young researchers can be unwilling to take risks due to concerns about career stability. So offering them a stable environment can have a big impact on the quality and ambitiousness of research results. I also would like to introduce a new initiative by the Japanese government to promote world-class high-risk long-term R&D. The government set up $100 billion US fund at JST, and the fund management profits will be used for the development of young human resources, such as doctoral students, and the development of university facilities and data linkage infrastructure. Let me finish by restating the importance of a convergence of knowledge and inviting diverse stakeholders together for the future. Together, we to explore new approaches to resilience, bridge science and society, and ensure everyone can benefit from the result. Thank you very much for your attention.
Thank you very much. Thank you for your great leadership at JST. I think this is, incredibly visionary what you put forward. So I'd like to move us now to the question period and thank all the presenters for very thoughtful and engaging, I think, presentation. So I'll start by asking a few questions and then get questions from the audience. My first question, I guess I will turn to Signe and Missionary, but for the others, please feel absolutely free as well. I guess the question is about and our strategies going forward. Of course, we have, but there are also long-term goals in research. So how do we ensure that while goals are being met, we're also preparing for the long-term ones. Who would like to start?
That's a very
Digby, would you
important
like to
question.
start? Go ahead. Go ahead. That's fine. Missionary, go ahead.
Okay, that's a very important question. In Japan, most of the research very conservative, become conservative because of the funding restriction. Most of the funding cover only 3 years or to 5 years. It's too short to challenge a big project or long-term project. So we need to change the system. We need short-term one, also long-term one. And that makes younger researchers to be more challenged and encourage them a lot. We started last year Forest, and we have very nice response from the universities and researchers.
I can come in as well, if I may.
Please.
Yes, please. I'm sorry. I was.
So, as I mentioned some of the there is echo. Can you hear me now? Yes.
Yes.
I hope you can. Now, some of these goals I've mentioned, which certainly are long-term goals as UN Sustainable Development Goals, which were already part of our program Horizon 2020, the previous 7 program, and they will continue to be at the core of this Horizon Europe program for the next 7 years. Also, climate change has been already certainly at the core of the previous program, and we continue to have just one very important target, which is that 35% of the program budget should be related to climate-related issues. So basically, tackling climate change. And certainly, these are the long-term goals. We have the program for 7 years. In addition, we also have the strategic programming, which is then for the first 3 years, and then for the 4 years, which then really sets the medium-term goals. And then we also have the work program, which is by 2 years. And this really goes already into the details. So we have the all levels actually part of the programming process.
Okay, thank you, Kay and Patrick. Would you like to answer this question, or would you like to weigh in?
I'm sorry, man. I keep dropping out of the conference, and I've got, for some reason, it keeps freezing, so I'm not catching all of this. But the long-term view, one of the reasons we set up the National Science and Technology by the Prime Minister is to make sure that thinking about science isn't a one-term issue for a government. It needs to cross governmental terms. It needs to be much longer term. It needs to be beyond party politics, and to try to make sure that we've got a system that can look 20, 30 years in the future and try and set the strategy that's required, including, of course, therefore, the basic research end of things. The second thing that we've done to try and tackle some of the big problems is to set up the new research institute we called ARIA, the Advanced Research and Innovation Agency, to try and tackle some of the big areas that, again, require long-term, really high-risk funding in order to get there. So this question of making sure there's enough in the system for long-term, and making sure that government ties itself to sticking with all the aspects from the research itself through to the supporting skills development and so on over that period is a key part of the new structure. And it's a crucial one. And it's the one that's easiest for governments to back out of, because it feels like it doesn't matter. Because it doesn't matter this year or next year or the year after. But of course, it really, really matters in the long run. And again, the international aspects of this and long-term programs, including Horizon Europe, are really crucial to make sure the long-term future is part of how we think about research funding.
Absolutely. Kate, would you like to add something?
Well, thank you. So actually, I've been appreciative of especially Horizon Europe and the framework programs for being able to support, 7 years or so of research funding. In the United States, traditionally, we've only funded scientific research 1 year at a time. So I'm excited that in some of the programs I talked about, such as the infrastructure bill and the Build Back Better Act, we are able to provide 5, 7, or even 10 years of funding for these research initiatives. And that, of course, is important, as we all recognize, because long-term goals require long-term patient research endeavors. So I'm excited about some of the policy initiatives that we are trying in the United States to provide more guaranteed longer-term funding for research.
Well, thank you very much. It's actually a good segue into my next question, which was going to be about, the SNT and whether it is ready to meet the challenges of building back better. I think all of us have had already many lessons learned from the pandemic about our system. Served us well for the past many years. Active countries, but I'm just wondering whether you maybe provide some thoughts on this question. If the system is ready, it's great. If you think there are things that can improve or enhance, given the challenges ahead that all of you have spoken to, I think would be interesting to hear your thoughts.
Well, thank you. I would like to think that our SNT ecosystems are ready, but I'm not sure that they are, because we have a lot to recover from. As I said before, our international collaborations and our ability to collaborate have been tested by the travel restrictions and other communications challenges of this pandemic. So I think that in addition to of course, supporting basic research, supporting translational research, we all need to devote some attention to helping our research enterprises recover from the many effects of the pandemic. And I know that for us, we are focused on policies in which we can be helpful in rebuilding international collaborations, in rebuilding international talent flows, and actually rebuilding the ability of our investigators to get back to their laboratories and to, in some cases, resume research that has been paused for over a year.
Thank you, Patrick.
I mean, to build on perhaps some of the positives, I mean, it's very clear that the whole system has gone through a major upset in the last 2 years. And as you've just said, there are groups that haven't been into their laboratories. There's been massive disruption. So what are the positives? First thing is, I think we've all learned that you can collaborate over distances actually rather easily by communication tools that were there before, but we weren't using in the same way before. So I think it's been possible to get a greater breadth of collaboration. And indeed, it's been possible to bring in people from just all around within an individual country to work more closely. So I think the communication tools we've got have actually enabled, and I hope they'll enable international collaboration. I think the second observation I would make from the UK, and I suspect it's true elsewhere, is scientists have come together in an interdisciplinary way to address very significant problems in a way that they haven't done easily before. And many of them have massively enjoyed doing that. So there's been a change in how people have thought about collaborations to answer big societal and government challenges, which has shown how well interdisciplinary work can occur and what impact it will make. And the third is science approaches, and I've mentioned some of the ones that are happening in the UK, are changing around the world in terms of funding mechanisms, in terms of duration of funding, in terms of an understanding of the need to go for high risk research projects that might fail, but if they succeed, they can be really important. And those things are changing, I think, the approach to tackling, again, the big societal challenges. So I think there are a number of things happening, and we're certainly looking at what the appropriate level of different forms of research funding, so diversification of research funding, is quite a topic at the moment in the UK, to try to make sure that we don't end up with the same old system, but actually where it's possible to enhance it, do so. And I suspect we'll see models like that occurring around the world.
Thank you very much. Anybody would like to add anything?
Can I just add one aspect, which I think can I add just one aspect, which I think that during pandemic became very, very clear, namely the importance of data, open data and data sharing, which certainly, well, all the research related to finding the solutions for the related to the pandemic was key. But I think this is something which would continue to be very essential if we'd like really to tackle the global challenges as an international community, which I think would be key. And just if I may, coming back very shortly to the previous question, how we actually then relate our program with the long-term strategies. For instance, as we have the long-term strategy of becoming climate neutral continent by 2050, or one of the missions in our research and innovation program is to have 100 climate neutral cities by 2030. So certainly also then the research program is related to really reaching these longer term goals.
Thank you. Any further comments on these questions, or should we move to the next one? Yes, please, Missionary.
Thank you. I would like to point out that problem we are facing in Japan. We have two problems. One is Japanese society is a really solid silo society. We need to break this society because COVID-19 clearly shows that the weakness of silo society. We need to collaborate over, depends on each specialty. That's why we started our program. We request young researchers form a team consist of different specialty and propose social issues to study. Another problem, I would say it's problem, but it's a character of scientists. Scientists, as Nobel Prize winner, almost all the winner emphasized, researchers are curiosity driven. We need enthusiasm for the research. But sometimes this enthusiasm fixes specialty. We have to introduce sociological issues to the basic research. and that's the funding agency's role, to promote a kind of platform, open platform, to discuss each other and find out important issues we are facing right now after 19. So we need to start a kind of new platform for the young, especially for the young researchers, to discuss each other. That's one of the important program for the funding agency. Now we feel it's very important. Thank you for giving me a chance to discuss.
Thank you very much. I think that we indeed need to have a science dialogues among the scientists, and society, and of course, and policy makers. I'm going to move to the audience questions. We have a few questions, and let's start with one. So, the colleague is mentioning that there are precedents where priorities that were considered to require concerted long-term efforts that transcended party lines, and so those goals were governed over longer times by multi-party cooperation. And the example given is Brazil's zero hunger strategy. So the question is, do you think that something like this could work in our countries, Canada and the Western democracies in your countries, and to get us basically out of the ineffectiveness and of trying to do science 3 to 5 years? I'd like to tackle this question. Okay, would you like to take a crack at it?
Well, I will say that, you know, as people engaged in science policy, we are always looking for ideas and successful examples of long-standing international collaboration and commitment. And I think, you know, between our nations, we've found numerous examples. That's to say, of course, we are still looking for more. I mean, I'm encouraged that, you know, for example, this UN process, the COP process, we are now, you know, 3 decades into that process, and it has continued to drive forward, you know, committed international cooperation on science, technology, and climate change. So that's one of the models that I stand with. For, you know, our nations, we've collaborated on numerous facilities projects, which of course require patience and commitment to make real and also to make operational. So we have numerous opportunities to learn from, you know, successful examples of where our nations have collaborated.
Okay, and since you mentioned the COP26, that the countries here on this panel, through their science advisors or equivalent, have signed a you know, an open letter encouraging the leaders, the researchers, and the public to work together to put science part of the implementation plans for climate change. So I definitely think that we need commitment there. I'm gonna there was another question, and I want to turn it maybe to you. It's about actually, Kay mentioned the 100 days mission for pandemic preparedness, and the question was, can you elaborate a bit more on this, and whether this is for therapeutics, or does it include trials, etc.? So the UK under the with this G7 presidency, and yourself were main instigator of this. So I'll explain maybe a little bit.
Yeah, thank you. The idea is obviously as part of pandemic preparedness to set a challenge for 100 days mission, which was from the time a new infection is identified as a pandemic or a major epidemic, to get to vaccines that can be ready for distribution at scale, an initial regimen of new therapeutics, and diagnostics which are approved and available for near patient use in 100 days. That's the challenge. And I think what has been interesting is that the G7 countries have come together around this challenge. Industry has been extremely engaged to try and get this right. Regulators are on board. And we've already started with a number of important steps in that direction. Now, all of the 100-day mission is completely dependent on there being a good surveillance system across the world that picks this up early. So there has to be a global pandemic radar to pick this up and to be able to get early sequencing. And the idea is that once you have that, to get the measures in place to be able to get vaccines, therapeutics, and diagnostics both discovered and taken through clinical trials so that we end up with the ability to distribute them in an equitable way across the world after the 100 days. That's the mission. It's thought to be possible for some things now, but the idea is to keep working to make it possible for all of the emerging threats that might occur. That may take a few years to get to that, but if we don't start now, then we'll never be ready for the other things. And some things already today, we got vaccines quickly this time. What would it take to get that down to 100 days? What are the measures that need to take place in discovery, in clinical trials, in manufacturing to be able to do that? And the G7 are leading on it. G20 has endorsed it. But of course, it has to be global ultimately, because this is about getting this across the world. So that briefly, Mona, is the 100-day mission and why I think it's important that the world embraces this in order to drive forward a concerted way of making any response in the future faster than we were able to do this time.
Indeed, and a very exciting, actually, example of the world coming together, both the public and private sectors, as we see it happen during this pandemic. Good, hopefully. So you've all spoken about the importance of international collaborations and also research and scientific discoveries, as well as ultimately innovation. So partnering with other countries can provide tremendous benefits. Are there specific strategies or best practices for international collaborations or pitfalls to avoid? And I'd like maybe to turn to Sidney maybe to start this, because of course the European Commission has negotiated with a lot of countries in the union itself, and then you mentioned as well collaborations outside the EU. So over to you.
Well, many thanks, Mona. Now, as I mentioned, I think that the first thing to underline is that our program is open to the world. So anybody in the world can actually participate in our program. The countries which are less wealthy can also be funded. The other countries, international partners, can also provide funding in order to collect. And then the closest form of collaboration is, as I mentioned, is association to our program, which means that you just pay into the program, and then you can collaborate on par with the EU participants, whether it's researchers or whether it's the companies as well, because we also have the public-private partnerships where also the companies are participating, as well as in the innovation pillar. So this is the closest form of collaboration, and in the past it was really open to the countries in the Europe's vicinity, and as I mentioned, now it's open to well, whatever country in the world which shares the high level of research and innovation, and also the same values with the EU. And in addition to Canada, with whom we already have started exploratory talks, we also have the technical discussions with Japan, with South Korea, with Australia, Singapore, New Zealand. So really, option is under reflection with several partners.
So thank you very much. Our time is coming quickly to an end, and I'd like to just maybe ask very quickly each one of you. So please take sort of 30 seconds to a minute max to answer the question. You know, we've talked about climate change, we've talked about pandemics, and we urgently need to accelerate solutions as well. But are there less obvious challenges where the need for science is estimated? And missionary, maybe we'll start with you for this one.
I would like to emphasize this time preparedness of mind. I mean, in times of crisis, first step to recover from the crisis is prepared mind. In our case, we experienced the last earthquake. And for the prepared mind, we need two things. One is education, long-term education. Another point I would like to emphasize is trust based on proper scientific information. We need to offer information, especially in the time of crisis, what is right, what is to offer the right information to the people, to the citizen, and we need to communicate, discuss. This is another point I would like to use.
Okay, I think you about the public. Like to highlight anything else? Then I'll go to Signe, and I will end with Patrick, if that's all right.
All right. Well, thank you. I did already point out that the challenge we all face is a loss of trust in institutions in general. And of course, the science enterprise is an institution, as is scientific information. I also pointed out that the pandemic has definitely exposed the challenge facing all of us in exposing the inequalities and inequities in our societies. But I'm here to say that, of course, scientific information and research can offer us not only an understanding of the problem based on data, but also potential solutions. So I think I look forward to maybe in a future year talking about science technology for societal recovery.
Thank you, and hopefully we'll do it in person. Signe, and then right away, Patrick, please.
Now, as one of my responsibilities in DG Research and Innovation is also citizen engagement. So what you've been speaking about is really music to my ears. But what I'd also like to highlight in this connection is that we are thinking and speaking a lot about technological innovation. But very important is also social innovation, because social innovation is something which is happening together with citizens, with the society itself, where also the society is at the service of finding solutions to the real problems that people face. So science with society and for society.
Thank you.
Yeah, my first comment would be the challenge is that I don't think there's a single area of government that doesn't require science input. And so it's that ubiquitous input of science and the scientific method, which I think is so important right the way across government. And I challenge you to think of a single area of policy where there isn't some input that science couldn't bring to that area. So that's point number one. Then to go to a very specific one, I think there's a big opportunity around education. And it's not just about how you educate people in the scientific method, but it's also about the application of new science and new technologies to ensure that every child gets the best possible ability to fulfill their potential, taking into account specific learning deficits and other things that require different approaches to teaching and learning. And I think there's a big opportunity to be much more inclusive in a satisfactory education for all, building on scientific advances.
Thank you so much. And indeed, I cannot think of a single area where science need not weigh in, whether it's for policy or a society. But thank you all for very engaging conversation and for highlighting the importance of interdisciplinary science, international collaboration in tackling our recovery. Science has helped us overcome the pandemic, although we're not completely out of the woods yet, but the future looks certainly brighter than it did go, and that's certainly thanks to science. So thank you all colleagues. Special thanks to the colleague from Japan. Good day and good evening to all of you, and to all the participants. Thank you for listening to us, and have a wonderful week at CSPC. Bye.